Chapter 6, problem number 47. A roller coaster, 375 kilograms, moves from A, 5 meters above the ground, to B, 20 meters above the ground. Two non-conservative forces are present. Friction does -2 times 10 to the 4th joules of work on the car, and a chain mechanism does 3 times 10 to the 4th joules of work to help the car up a long climb. What is the change in the car's kinetic energy from A to B? Okay, so we're looking for delta KE from A to B. So it's KEB minus KEA from A to B. So the coaster goes from A to B. A is at 5 meters, B is at 20 meters. And we want to know the change in kinetic energy between those 2 points. Okay, the mass of the coaster is 375 kilograms. Again, this is the unknown. Friction does -2 times 10 to the 4th joules of work. And the work done by the chain drive is equal to +3 times 10 to the 4th joules. So this work puts energy into the coaster, friction takes energy out of the coaster. Okay, the chain drive does work from A to B, friction does work from A to B, force of friction. Okay, so let's do this. So the net work from the work energy, kinetic energy theorem, is equal to the change in kinetic energy. Net work is equal to the work done by the chain drive plus the work done by friction plus, don't forget about gravity, the work done by gravity. And adding those 3 up, we get the change in kinetic energy, which we are trying to find. So the work done by the chain drive, we know. Work done by friction, we know. How about the work done by gravity? Well, that's equal to the negative of the change in the gravitational potential energy. Which is equal to mg times 5 meters minus mg times 20 meters. Right, remember the change in potential energy is the final potential energy minus the original potential energy. So that would be mg times 20 meters minus mg times 5 meters. But we have to take the negative of that. So we get mg 5 meters minus mg 20 meters. So let's put in the numbers. The work done by the chain drive is 3 times 10 to the 4th joules. Work done by friction is 2 times 10 to the 4th joules, negative. We have to add to that the mass, 375 kilograms, times g, 10 meters per second squared, times 5. Okay, now I'm going to factor out the mg, and then I can multiply this by 5 meters minus 20 meters. And that's equal to the change in kinetic energy. I'll put that over here. So delta KE then is equal to all that. Okay, so let's see what we get. keep on making mistakes here. 5 minus 20 times 10 times 375. Okay, I have to add to that negative 2 times 10 to the 4th, and add to that 3 times 10 to the 4th. And I'm getting negative 46,250 joules is the change in kinetic energy. So, in other words, the final kinetic energy is less than the original kinetic energy. So the coaster slows down as it goes from A to B.